Okay, so today in your science lesson, you're going to be carrying out a virtual experiment. And as with all experiments, we want to come to a conclusion at the end. In order to get to that conclusion, you're going to collect some data, you're going to draw a graph, and then from that graph, you're going to draw a conclusion. So over the last few lessons, we've been looking at the rate of a chemical reaction, basically how quickly the reaction happens. Okay, and today we're going to look at how temperature affects the rate of reaction. Now we're going to use this little simulation. So there's a link in Google Classroom. When you get on, you just have to close down the first window. Okay, and it's a bit strange to begin with. You've got to open up this cupboard and you've got to take out all the equipment that you're going to need. So this is a hot plate. This is like our heater, and we can change values on it to take it to whatever temperature we want. We're going to have a beaker of water. There's some ice here. We're actually not going to use that. There's an antacid tablet, which we are going to use, a thermometer, and a stop clock. So the key thing here is we want to know, how does temperature affect the rate of reaction? So our question is on the board behind there. So our independent variable is the temperature. That's what we're going to change. And we're looking to find out, as our dependent variable, the rate of reaction. Now we're going to get the rate of reaction from how quickly or how long it takes, is probably a better way to say it, how long it takes for the reaction to happen. Now, we're not going to use the ice, because if we put the ice in, that's not going to be a chemical reaction. That's going to be a physical change. And I want a chemical reaction here. So notice if I put this antacid tablet in, it will react with water. And we see this reaction. Now, over time, that tablet's going to get smaller and smaller. And eventually it's going to be so small that we can't even see it anymore. The reaction appears to have finished. And at that point, we're going to say the reaction is over. Okay? So there we go. Now, what we're going to be doing is setting this up at different temperatures. So if you click on this dial, I've had a few issues with this. Sometimes you press reset and you reset the lab equipment and it's easier to do again. So we're going to start at 0 temperature, and I'm going to ask you to do it every 2. So you're going to do it 2, 4, 6, 8, 10. Now these values on the hot plate dial are not the temperature. You've got to take the temperature from the thermometer. Okay, so if you look carefully at this, I don't know how well you can see on the screencast, but that's about 20 degrees now. If I say put that on to 6, okay, notice the alcohol's going up the thermometer. This time it's at about 70. So you're going to set the temperature by changing the dial, okay, but I want you to give me the temperature that's written on the thermometer, okay. Now, in Google Classroom, I've linked you to a results table here. So on the results table, it gives the hot plate setting. So 0, 2, 4, 6, 8, 10. But for each of these, you need to give me the temperature on the thermometer in degrees Celsius, because that's really the key thing I'm looking at. How does temperature affect the rate of reaction? Now, what we're going to do is we're going to do 3 trials for each temperature. Now, I want to see how well this simulation works. This is the first time I've used it. So I want to see if we do repeats, is it always the same, or are there some differences? Sometimes when they make these simulations, they deliberately make it like real life, so that every time you do it, it doesn't give you exactly the same results. So you're going to do each one 3 times, and you're going to work out the average time it takes for the tablet to finish reacting. And when it finishes reacting, you're not going to see it anymore. It's going to have disappeared. The bubble's going to stop. There's going to be no evidence of a reaction rate. And it's going to be these 2 columns in blue that we're going to plot a graph of. Okay, so you're going to put your thermometer in. You're going to have your stop clock ready. Okay, what I'll do here, so I pick up my antacid. At the moment, I'm at 70 degrees. I drop it, and I drop it, and as it goes in, I press the stop clock. And my stop clock here is just timing, timing, timing. And I'm going to leave it to time until the reaction appears to have stopped. Okay, so I would say that's 28 seconds. And I would put 28 seconds for my first try at, what was the temperature? At 70 degrees. So I'd be looking, 70 degrees is when it's on 6. So I'd go to my results table. I'd say 6 here, type in 70 degrees as the temperature, and then put my time in. Then I'd do it twice more, see if I get the same result. Okay, so at the end of this, we're going to have some results. We're going to have some data that's going to help us answer this question. How does temperature affect the rate of reaction? Now, one of the most important things, though, is we're not directly measuring the rate of reaction here. We're measuring how long the reaction takes. Now that's not quite the same thing as a rate of reaction. Rate of reaction is how quickly does it react. And actually, the time it takes is kind of inversely related to the rate of reaction, because if the reaction happens really quickly, the reaction doesn't take long. Okay, if the reaction happens very slowly, it takes a lot of time. So bear in mind that if your time is long, the rate of reaction is slow. If your time is short, the rate of reaction is quick. So think about a really slow reaction like rust. Rust is when iron reacts with oxygen, and it takes many years. Well, it takes many years, it's got a long time for the reaction to happen. That means that the reaction is very slow. And then you look at something like an explosion when a bomb goes off, okay? That reaction takes a tiny amount of time. That means it's got a high rate of reaction. The rate at which the substances within the bomb react are extremely quick. So you're going to carry out this virtual experiment. You're going to put your results into this results table, and then we're going to use a graphing program we used a few weeks ago to plot our graph. Okay, hopefully you can remember this one here. Okay, now you're going to put your data into these columns here for A and B. I'm just going to make some stuff up for a minute. These are not real results because I don't want to give away what you're finding. Okay, so let's put some. Sorry. Right, so I've made up some results here. These are not going to be like the results you've got. Okay, now once I've got my data in here, okay, I then want to plot a graph. Okay, so I press on this trace plus trace button at the top, and when I do, we're going to go for a scatter graph. We're going to add a best fit line afterwards. Okay, we've got to choose data now. We've got to get this the right way round. Okay, whenever we do anything where we're looking at rate of reaction, we always want to have the time on the x-axis. So the time needs to go across the bottom. Okay, and the temperature goes up the side. Okay, so we're looking at how does temperature affect the rate of reaction. Sorry, I said that the wrong way around. Okay, our independent variable, okay, here is the temperature. That's what we're changing. Okay, so we're looking at how temperature affects the rate of reaction. So I've got to choose the right variable. I've just made up my results, so actually for me it makes no difference. But for you, you've got to make sure you get them in the right place. So A and B need to be the right way round. Make sure you've got your independent variable on the bottom, which in this case is what we change, the temperature, and up the side what we're going to measure, which is going to be the time taken for the reaction. So I put these in the right place. You can see I've got a graph. It's not a straight line, okay? And in a minute I'm going to plot a best fit line. But before I do, let's remind you, you've got to give it a title. I always think a good way to start is graph to show. I'm not going to give them the rest. You're going to do that. You're going to make sure you've got labels on both axes just by clicking here. Okay, you can decide what it is that you're measuring, and it should have a unit as well. So make sure you don't forget those. And once you've done that, you click on Analyze on the left-hand side and Curve Fitting. Okay, when it says curve fitting, it can be a straight line or a curve. Okay, and you press the fit, and you select a trace. There's nothing to select; it's just trace 0, so you've only got one choice. At the moment, it sets linear, so it tries to put a straight line through. Now, the straight line doesn't actually look too bad, but you can see that it starts off below the line and then goes above and below again. You can see that a curve would be a better fit. So instead of the linear, there's all kinds of mathematical equations you could use, okay? Now, I could, for example, try a quadratic. Now, it doesn't matter that you don't really know necessarily what exponentials and Gaussians and quadratics are. You're just going to do a bit of trial and error, find something that fits. Now, you can see this curve quadratic fits almost perfectly for mine. Okay, your data are going to be different because I've made mine up, but I want you to find something that fits the data as perfectly as you can. Remember, it might not be possible to fit it exact. There's always likely to be in real life some kind of either anomalies or just a little bit out uncertainty in the data you've collected. So don't worry if the line doesn't go for the points. That's fine. That's normal for science. Okay. Now, once you've done this, you're going to take a screenshot of your graph. Can I ask that you take a screenshot of the graph only? I don't want the table and all the rest of the bits here. I just want the graph that we're of interest in. Okay, and you are going to put that into the document that's linked in Google Docs. Okay, so I'm going to use my screen cutter tool here. I haven't labeled mine yet, but you're going to make sure you do. So I'm going to just cut this. I'm going to copy it, and I'm going to put it into this first box. Yeah, I'm hoping to. And there's my graph. Okay. get rid of the rest of the space in the box. Looks nice. Okay, so yours is obviously going to have a title and labeled axes as well. Now, the last task is you're going to write a conclusion for this experiment. So what can we find out? Now, remember, what was the question? How does temperature affect the rate of reaction? Well, you're going to do it in two parts because there's a describe, okay, and there's an explain. Okay, now describe, remember, is you're going to tell me about the shape. Okay, what is the shape of the graph? Okay, how does your independent variable affect your dependent variable? So make sure in your conclusion you're mentioning your variables. How does temperature affect the time that the reaction goes on? And use that to tell me, okay, how does temperature affect the rate of reaction? Now, the next bit is to explain why. Now, there's a video, I will link it into this document, but it's already linked on Google Classroom. It says here, explain why temperature affects the rate of reaction. Please watch the video, effective temperature on speed of reaction, because this is going to help you. We've already seen some in recent lessons, a little bit of information on this, but if you can watch the video, I want you to see why is it that hotter temperature of water makes a difference to how quickly the reaction happens. So the first one is just describing the shape of the graph. What shape is it? The second one is explaining why. Why is it that temperature makes a difference to the rate of reaction? Okay. So at the end, this is the main document I'm going to be checking. I want to see that you've got a graph here, that you've written a description, and you've written an explanation. I'll also have a quick look to check you've got some data in your table. Okay. If you've got any issues, then as always, send me an email or post a question in the stream on Google Classroom. Okay. Thank you very much.